In this video, we will be talking about partial fraction decomposition. Now, this tool might not make sense to you right now, but it will when you get to Calc 2, because it's a tool that we use to evaluate integrals. So you're not going to use it in Calc 1, but you will be seeing it a lot in Calc 2. So right now, as we do some of the problems, you'll see why it might be what is the whole point of this. But you'll see the point by the time that you get there. And actually, you might have to review a little bit right afterwards because you might forget this process again. But let's just go quickly provide you with a problem where you might have seen before. And then we're going to break it apart and see what partial fraction decomposition is. So let's look at these two rational functions. So we got two rational fractions, 2 over x minus 3, and then negative 1 over x plus 2. So let's go ahead and combine these guys. So right now we have 2 over, oh, this looks a little bit too much. So get 2 over x minus 3, and then plus negative 1 over x plus 2. So what you're going to do is, one of the things that would be really useful to combine these guys is to make them denominators the same. So one of the things that I like is, like, if this has an x minus 3, it meets what the other guys doesn't have, what the other one has. So I'm going to multiply this guy by x plus 2 to both top and bottom, because that guy is the thing that you have on the denominator for the second fraction. And I'm going to do the same thing, but for this fraction. So this fraction is going to get an x minus 3. And you're going to get an x minus 3 on both top and bottom. So kind of finding the least common denominator. So what you're going to end up with is 2 times x plus 2. On the denominator, you just get x minus 3, x plus 2. And then plus a negative 1, x minus 3. And on the bottom one, I'm going to write the x minus 3 first, and then followed by the x plus 2. And now you'll see that both denominators are the same, so I can actually combine this into one single fraction. So I can have x minus 3, x plus 2. And on the top, let me FOIL this guy out. So we'll get 2x plus 4. Let me FOIL this guy out. You get negative x plus 3. So then what you end up getting is x on the top, then a plus 7 divided by x minus 3, x plus 2. Okay? And furthermore, what you can do is you can also FOIL the bottom if you want. And typically the way that problems are going to be like is we're going to have the FOIL on the bottom as well. So we're going to have x squared plus 2x minus 3x minus 6. So you're going to have x squared minus x minus 6. So this is how you would combine two rationals together to form one rational. Now, the whole point of partial fraction decomposition, because this is something that you've done in Algebra 1 or Algebra 2, but one of the things that you want to be able to do is, how do we go backwards? How do we start with this rational and break it up into two basic fractions? So that's what the whole point of this section is. We want to be able to go backwards. Okay, and that's what we call partial fraction decomposition. So partial fraction decomposition, the partial fraction decomposition of p of x divided by q of x, so a rational function with non-repeated linear factors, and the degree of p of x is less than the degree of q of x, so you have p of x divided by q of x, is equal to a1 over a1x plus b1 plus a2 over a2x plus b2, okay, plus all the way to a sub n over anx plus bn. Okay, so basically, q of x has many factors, so these guys are all the factors of q of x, and then on the top, you're going to have some constants. So all of these numbers right here, a1, a2, and an, are all constants that need to be found, okay? So I think it'll make sense for us to kind of do an example so that you can kind of see what exactly we're doing. Now, one of the things that we have to be very careful with is that in order for you to do this type of analysis, or to be able to do partial fractions, we require that the degree of the numerator, right, of p of x, and I'm going to write it just numerator, the degree of the numerator is less than the degree of the denominator. Okay, so if we do have that, we can go ahead and separate it in this fashion. Now, what happens if our degree of our numerator is greater than or equal to the degree of the denominator? Well, in that case, we will use long division to make it a little smaller, okay? And then use partial fraction decomposition on the leftover terms, okay? So let's not worry so much about long division just yet. So here are some of the steps. So here are useful steps. So the first thing that we want to do is factor out the denominator. We're going to break up the factors on the denominator into the sum of fractions with one variable on the numerator. So you'll have like A, B, C. So you can have it as A1, A2, AN, but it's better to just have A, B, C. Multiply all sides of the equation by the common denominator to eliminate the fractions. Okay. Expand the right side of the equation and collect like terms. Then set coefficients of like terms from one side of the equation to the ones on the right to create a system of equations. And then solve the system for the numerators. So this seems like a lot. I think it's better for us to just do an example to be very aware. So in general, this method works even if they are repeated. And I'll go ahead and do an example in the next video so you guys can see how we do this type of math. Actually, you know what? Let's go ahead and just do it right now so that you can kind of see now that it's kind of like fresh in your mind. So let's go ahead and try this example right here. So we're going to find the partial fraction decomposition of the following: x plus 7 divided by x squared minus x minus 6. And you see that this problem is actually the one that we just did. X plus 7 divided by x squared minus x minus 6. And we already know what the answer is. It should be these two fractions. So let's go ahead and use partial fraction decomposition to break this up and go backwards. Okay? So let's go ahead and do that. So the first step to do this, and you guys can go ahead and take a look at this, is factor the denominator if necessary. And a lot of the times you will have to factor the denominator. So you have x plus 7 divided by, and let's factor out the bottom. You have an x, 3 and 2. This one should be a negative, this one should be a positive. Okay, x minus 3, x plus 2. All right, now the next step, now that we factored it, our next step, so we're going to break up the factors of the denominators into a sum of fractions, okay, with a variable on the top. So I'm going to break up, so I'm going to pretend that the x plus 7 is not there. I'm going to write a, which is a number that I don't know, divided by x minus 3, plus b divided by x plus 2. Because this is essentially what I want. Because if you look back in our previous problem, when we were doing it, that's exactly what we wanted. We want something over x minus 3 plus something over x plus 2. So now our goal is to figure out what these two numbers are. Now the order doesn't matter which one is a and which one is b. So you could have easily said a over x plus 2 plus b over x minus 3. The order doesn't matter. You will still get the same answer. All right. Now that we have it like that, how are we going to figure out what a and b is? Okay. So our next step is to multiply all sides of the equation by the common denominator to eliminate fractions. Okay, so this is what I'm going to do. So one of the things that I like to do is that I like to make this into the other side. Okay, so imagine that, well, let's go ahead and do it this way. Let's imagine that I'm multiplying everything by this guy. So we're going to multiply this entire equation by this guy. By x minus 3 and x plus 2. So every single little term is going to get x minus 3 and an x plus 2. So I'm going to go ahead and write it out. So I get x plus 7 divided by x minus 3, x plus 2. So I'm going to write everything the same. And every single term is going to have an x minus 3, x plus 2, x minus 3, x plus 2, x minus 3, x plus 2. So every single term is going to get that factor. Okay, so I'm multiplying everything by that guy. The reason why I'm doing that is that I will cancel out the denominator. So you can see that here, everything goes away. So this guy goes away with that guy. For this guy, only the x minus 3's go away. And for this one, only the x plus 2's go away. So what I'm going to get is x plus 7 is by itself over here. You only have an a here times an x plus 2. And then on the other side, you're going to get plus b, and you're going to have an x minus 3. Okay? All right, and now let's go ahead and FOIL this out. So you get x plus 7 equals ax plus 2a plus bx minus 3b. Okay. Okay, so now what are we going to do? So let's go back to our steps now that we FOILed everything out. So I multiplied everything through. Okay, now we expanded the right side and collected the terms. So set coefficients of the like terms from the left side of the equation equal to the right side of the equation to create a system of equations. Now, why would we do that? So basically, this is an equality, right? This is equal to each other. So that means everything that has an x, so for example, this x, this ax, and this bx, they all should be equal to each other. So if you think about it, let me write it up here. This x is equal to this ax and this bx. Okay? Because if this is really an equality, this left-hand side should equal to whatever has an x on the right-hand side. And we're going to do the same thing to the other side. So this positive 7, which is a constant that doesn't have an x, since it's an equality, this should equal the 2a and the negative 3b. So that means that guy is just equal to the 7 is equal to 2a negative 3b. You can see here the x's don't really matter. You can imagine like that we're factoring out the x's. So all we just have is like instead of the x we have a 1 equals a plus b. Because we don't really need the x's. And now what we have is a system of equations. Let me write it like this. Let me write it right below it. And we need to solve it. So now here's where you can use substitution, elimination, whatever you want to use. So one of the things that I'm going to use is I'm going to use elimination. So I'm going to go ahead and try to get rid of this 3b by multiplying the top guy by a positive 3. That's going to give me 3 equals 3a plus 3b. And then what I'm going to do is I'm going to add it to this other second part. 7 equals 2a minus 3b. So you can see that the 3b's go away. So I'm left with 10 equals 5a. Divided by 5, a equals 2. So now that I know what a is, this guy, I'm going to plug it into any of these other equations to get what b is. So it's easier to probably plug it into the 1 equals a plus b. So I'm going to have the 1 equals a plus b. And I'm going to plug in this 2. So 1 equals 2 plus b. Subtract the 2. So I get that b equals negative 1. So now I know what the answer is. So I'm going to just plug it back into the original. So we knew that x plus 7 over x minus 3, x plus 2 was equal to a over x minus 3 plus b over x plus 2. So plugging it in, you get that 2 over x minus 3 plus negative 1 over x plus 2 is my solution. And as you can see, this solution is exactly the same as the one that we have up here, which is actually pretty cool. So yes, this involves a little bit more work than it does. But we're going to do some more examples in the next couple of videos so that you can get used to doing problems like this.